Hi everyone, this is a video report on Signals and Systems Lab Experiment 4. In this we are asked to create MATLAB functions for impulse response and convolution of four systems. So we were given four inputs, PPG, ECG and speech signals. We are asked to find the impulse response, and then by using these two we will find the output of the system using convolution, and then based on the outputs and inputs we'll try to tell the behavior of these systems and mention the properties of these systems. So let's get started. The first system is 1/3 of xn plus xn minus 1 plus xn minus 2. As we can see, if the input is delta, then it is non-zero only in the interval 0 to 2. So I have taken an interval 0 to 2, and then I have defined the impulse response in this way. As if the input is delta, then we get the impulse response of the system. And where did I define the delta function? In the last, I defined this delta function such a way it takes an input that is an array, and it returns the values of delta of these inputs. So as we know, if it is equal to 0, then the value will be 1, and if it is other than 0, it will be equal to 0. So by using that function, we can find the delta response of the system. And then I have used a function called convolve. I have defined it here in the ending. The length of the convolved system will be equal to length of the input signal plus length of the impulse response minus 1. And then I have used this function for padding zeros because we need an array of this length L plus K minus 1. So I have used this padding. So then I have convolved this impulse response and input signal to find the output of the system, and then plotted this for this system. So these are the inputs and outputs for the four signals. And second system is a moving averaging system. Here it is sigma of x of n minus k of k equal to 0 to k equal to m minus 1 divided by m. So for m equal to 25, 50 and 100, we were asked to find this, so just change the value of p here and we can change the value of m. I have defined it in that manner. So here the impulse response is found using this for loop, and then when we found the impulse response, we can directly convolve it using the convolve function. So finally these are the outputs, and here if you carefully observe, we are getting the low frequency component of the graph. So let us remember this. The first and second system are giving low frequency components of the inputs. And the third system also, I have defined the impulse response in a similar way for this system, and then found the output. So these are the inputs and outputs. Here the high frequency component is being returned as an output, and the low frequency component is not there in the output. Let us see for the last part. the system is x of n minus x of n minus 2 divided by 2. So again we define the length of the interval in which this function is non-zero, and then use the convol function and get the outputs. Here also the high frequency component is returned as the output and the low frequency component is left behind. And so let us answer the part B of this part D. Based on our observations, the first and second system are low pass filters and third and fourth systems are high pass filters. The last question is based on these difference equations, now define another difference equation which removes the trend line. So let us take for the first signal. Let us actually when I am loading the names of these matrices are visible in the workspace. So I can easily change the names. Now I have found the output of the second system, as you can see here, for m equal to 100, and then remove this output from the input to remove the base trend line. So first I have found the trend line because it is the low frequency component, and we've seen that the second system is returning the low frequency component of the graph. So when we remove it, we get the this length of the system is 1600 and I've given 1000, so it's showing an error. But see, the input signal is this of length 1600. Now I found the output of the system 2 for m equal to 100, and then I've removed this from the input and I've got the output without baseline Wanda. And so we can do it for the other systems by just changing the name of this matrix here. And finally we were asked to tell about the properties of these systems. The system 1 is memory system because it depends on past inputs. It is causal because it is depending on the past and present values, and it is not depending on any future inputs or outputs. And when we fix the when we bound the input, the output is also bounded. So it is a Beaver's system. It is a stable system. And the second one is also a memory system and causal system in similar terms, and it is also bounded because here when we bound the input, the output is also bounded. So it is also stable system. And the third system is also depending on the past values. So it is a memory system. It is a causal system because it is depending on the past and the present input values. And it is bounded because if we bound the input, the output is also bounded. And in a similar manner, the fourth system is also memory, causal and bounded system. It is stable system, and clearly the output of these systems is a weighted sum of inputs, past and present inputs. So it is an FIR system because the impulse response here is finite. We were able to give the arrays in the MATLAB because the length of the impulse response is finite. And thank you.